Hello everyone. So today I'm going to explain the coding part of double linked list or doubly linked list in Python. So as you all know, I think doubly linked list this is how a node will be. So it will consist of the previous node which will be pointing to the node before this node, and next node which will be pointing to the next node after this. So this will be the value part. There will be three parts inside a node. So as you can see here, there is only two nodes present. So we will call this the first node as head node, and the last node will be, we can identify the last node by checking the next node of the last node, which means it will be pointing to none. So this is how we can identify a double linked list. So as we can see here, these two nodes are linked. How? So this next node is linked to the next node, uh, and the previous node of the next node is linked to this node. So this is how every nodes are linked. Okay, as you can see here, if the value is 12 here, then this 12 node will be linked to the next node by using the next node, and we can get this node's value for if we are doing a traversing backward direction. We can use the previous node of the next node. So that is one of the biggest advantage of double linked list, uh, apart from the single linked list. So let's see how this works. So as we can see, we need to create a node at first. So what I'm going to do here, I'm going to create a class for doubly node. So inside this class, I'm going to create a constructor. So in this constructor, we need three things as I have explained here. We need previous node, value, as well as next node. So we need the value, then previous node, which I'm setting to none at first. I will tell why. The next node, which is also setting to none. So I'm going to set like this, value is equal to value. I'm going to set everything. Self dot previous node is equal to previous node. Then self dot next node is equal to next node. So what I have done here is, at first our node will be only having a value, and its previous node will be pointing to none, that there will be no nodes before it, and the next node will be pointing to none. So this is how we are creating a node. Now we are going to the main part. So we are creating a doubly linked list. Okay, so as I have said, at first there will be a head pointer, head node. So for that, whenever we are calling this function, we need that to be assigned. So I'm gonna do it like this: head, which I'm setting to none at first, as there is nothing, no data inserted. Self dot head is equal to head, like this. So there are the now we see the different operations that we are going to do in this double linked list. So different operations might be, the first one will be inserting to back. Next one will be inserting to front, then inserting at a specific position, then deleting from front, then deleting from back, then deleting from a specific position. So these are the 6 operations that we'll be doing. So this is all it is. So at first we'll be doing that inserting to back. So for that, I'm going to create a function inserting to back, where I have given the self as it is inside this class. Then we need the value that has to be inserted. So I'm going to set give it as value. So at first we have to create a node. Okay, so as I will be passing on value 12, so 12 will come here. So it is just a value. I have to create a node. That's why I have created this class. Okay, so we need the node. We have to create a node. So what I'm going to do is, I'm going to say give the name as new node, and I'm going to call that function, call that class. I'm going to create an object with that, and I'm going to pass this value. So what it is happening, as we all know, value will be passed here, and its previous node and next node will be set to none. Now I have created the node. New node will be the value. So there is, so we are going to insert it at the back. So at first we have to check whether the list is empty. If it is empty, we can directly insert it there, or else we have to traverse till the last element. That is how it works. So we are checking if a first node is, if the list is empty. list is empty. So if self dot head, that will be the first node, is none, then I'm gonna push it to the first node itself. New node. I wanna return it. That's it. So if it is none, then I'm directly pushing it there, or I am traversing till the last node. So as I have said, the last node we can identify it in the way that the last node's next node will be none. So as we need to traverse it till the end, so we need to pass this self dot head into another variable, that is current node. So we are using this current node to travel till the last. So for that I'm using while loop if current node dot next node. So I'm going to travel till the last node. How I'm traveling, like this one, current node is equal to current node dot next node. So yeah, by this way I'm traveling till the last node. So every time, so at first this will be the current node. So current node is equal to current node dot next node. So this next node will become the current node. So until the next node becomes none. Okay. You can also give like is not none likewise. So now after this while loop, when it ends, we have reached the last node. So now we are going to push it into the last node's next node. So how it is, I think you already get it. So current node dot next node is equal to which one, the new node. Okay, so what I've done is current node's next node will become this. Consider this as my new node that I'm going to insert, and this is none. So what I'm going to do is this next node will become my new node, and new node's previous node will become the current node. So new node dot previous node will become the current. Okay, and I'm gonna return. So this is how it works. So let's see how whether it is working. So I'm gonna we need to print it. So printing the linked list. So I'm gonna create the printing list function, and there is nothing needed. So at first we have to check whether the list is none. If it is none, there is nothing to be printed. If it is none, then I'm directly returning nothing is printed. Then else I have to traverse through the list, linked list, and how to print each element. So while current node, so so no, current node is not initialized, so current node is equal to self dot head. So I'm going to traverse through this till the end. I have to take the last node itself also. That's why I'm not giving current node dot next node. So here I have given while current node, then current node is equal to current node dot next node. Okay, like this I'm traversing as we have already said before. So before that I have to print the value of each node. So value I'm giving current node dot value, which means I will print that particular value while traversing through the node till the end. And I'm gonna give a symbol and a symbol like, okay. So this is how it works for printing. Okay, let's see whether it works. I'm gonna create an object for the class. So doubly linked list I'm giving a d1. So doubly linked list, I have created an object for the class. I'm going to call the function insert to back. So at first I'm giving 11. Then I'm gonna insert one more 12, and I'm gonna print the data. Okay, there's a 1 minute printing list here. 11 12. Now we can see at first 11 node is created and then 12 is inserted to the back of the list. So inserting to front is same as the inserting to back, but we know there is no need for traversing to the last. It is very simple. So inserting to front, I'm giving the function name and self, and we need the value. So same like before, we are now going to create a new node, that is doubly node, from the value that is inserted. Now, at first we have to check, as I said, whether the linked list is none. If yes, I'm gonna add it to this one, and I'm gonna return it. Or else, what I'm gonna do is, if it is not none, then we know that this is, consider this is the linked list, whole linked list. There are two nodes. So this is the first node, which is considered as a head node. So what I'm going to do is, I'm going to insert a new node. I'm going to insert a new node in front of this. So I'm going to set this new node's next node as the self node. Okay, new node's next node of this new node's next node as this head node. Okay, Then I will show how it works. So the new node dot next node is equal to self dot head. Now self dot head dot previous node is equal to new node. Okay, same like this one as we have done here. Current nodes next node is the new node dot previous node is current. We are linking both of them. New nodes next node I'm setting to this self dot head, and self dot head dot previous I'm setting to this node. And we have to set it at last. Self dot head is new node, or else it won't work, because we have to change at last, because as this was the head node, we have to change it to this one. We have to change it to this one. So that's how it works. Let's see whether it is working. So I'm gonna insert different. I'm gonna insert 10. It should come before that. Yeah, it is coming. I will insert one more value. Insert it. Yeah. So now we got it. How we can insert to the front. Now this is one of the important function. The next one, that is inserting to a specific position. Specific position. So for that, what we need is that inserting to specific position means in this data, in the output we can see 9, 10, 11, 12. So this will be the first node, that is 0, 1, 2 and 3. So consider we have to insert at the second position, 0, 1, 2. So after 11 we'll be inserting one node. Okay, so we are creating a memory at that time. As we know, linked list and array is difference. So we have to traverse through the list, and we have to search for that position where we have to insert. So that's how it works. So we need the value that is to be inserted, so we can see how it works. And we need the position that we are going to insert from the user. We need the data. So as usual, we have to check if set. If it is none, then I'm gonna insert the new one. Okay, node is equal to doubly the value. Okay, then I'm going to return it. If self dot head equal to none, okay, is none, I'm going to add this. Or else what I'm going to do is, as we have done, we are playing this, we are searching for that position and we are going to insert it there. So we can't take self dot head directly, so that's why we are passing it or saving it to a temporary variable, uh, self dot head, sorry. So in this current node, so same like previously, we are searching for that current dot, that position. So until, so we have to check two conditions, whether it becomes none, and I'm going to do like count is less than position. So I will tell why I'm doing this. I will explain the code. Count equal to 0, I'm setting to first. So every time, so we have to reach that particular position for inserting the data. So it should not be the last node. Like if the count is greater than the length of the linked list, it will cause an error. So we have to give this condition also for that, and I'm going to increment the count every time until it reaches the position. So count plus equal to 1, and current node is equal to current node dot next node. So now I have reached that particular position. So now what I need is I have to insert the data. So consider this as the current node, and I have to insert the node here. Consider that this is the new node that I'm going to insert. This is the new node that I'm going to insert. So what I'm going to do here is the current node's next node. I have to break this link. So before breaking, I have to set the previous node to this one. So what I'm going to do is the current node's next. So new node. This is the new node. New node's next node is equal to, I'll tell you how it works. So new node dot next node is equal to current node dot next node dot previous node. Okay. New node's next node is equal to, so new node's next node is equal to current node's next node dot previous node. So we have made this link to this one. So the link will be to this part. So we have broke this link. So this will not be there anymore. Now as we can see, current node's next node also we have to set to that current node next node. No, new node's next node we have to set to current node next node. Okay. Now Okay, current node dot next node will be new node. New node dot previous node will be current node. New nodes previous node will be current node. New nodes previous node will be current node. Uh, New nodes next node also we has I. Okay, new nodes next node will be current nodes next node. Sorry, this is how it works. So new nodes next node, that means our new nodes next node will be current's next node at first. Okay, then current nodes next node is equal to new node. As we have broken this link, we have to set it to this new node, and new node's previous node will be current node. Now we have to see if the, yeah, that's all. I will explain it. Given dot insert a specific position. I'm going to give the value as 99. I'm going to give the position to, okay, yeah, 0 1 2, and the second position it has added 90. Let's give the last position. Let's see how it works. 0 1 2 3 4. D1 dot insert to specific. The fourth position I'm going to give 100. Yes, perfect. So what I have done here is, let's see, let's compare it with the code. uh, the new nodes, this is the new node. So new nodes next node, I'm linking to the current nodes next node. As we have seen, this is the current nodes next node, so I'm linking that next node to the new nodes next node. So this link is broken, this link is broken. Okay, now the current nodes next node, it's broken. We have to create it first, is the new node, and new node's previous node is the current node. So we're not giving like current nodes next node previous node is equal to new. So new nodes next node previous node is equal to the new node. Why? Because it may be empty, so it will cause an error. So that's all is enough. So this is how it works. When you look deep into it, you will understand the working of it. Now we have finished all the inserting ones. Now we are going for the deletion. Deletion, same like this. There is three: front, back, as well as specific position. Front and back is simple. Specific is same like this, inserting, and there is a little change. So we are going to create delete front. I'm going to create the function. So self. There is no need for giving the value and all. So at first, I'm gonna check if it is none. Is none, then I'm directly returning it. Or what I'm gonna do is self dot head. This first node's next node will be the self dot head. I think you understand. So as we all know, this is the first node. This is the self dot head node. We have to change this head node to the next node because we are deleting this. So how we can do is that self dot head is equal to self dot head dot next node. That's all. So I'm gonna check. Oh, sorry. I'm gonna set the first node to the first node's next node. That's all. That's only needed. So delete front. Okay, the 9 is deleted at first, and it's starting from 10 to 11 to likewise. That's all with so delete dot front. If again give that, then 10 will be deleted. So now we are going for the delete from back. So if you think, you can pause the video and you can think for one moment how we can delete from back. Same like inserting to back, we have to traverse till the last node. So that's how it works. So if self, same instance I'm giving, self dot head is none, then self dot, then return, or we have to traverse till the last. So I'm gonna create a current node that is self dot head. So while current node dot next node is not none, okay, then current node is equal to current node dot next node. Now I have reached the last node. So consider this is the last node as I have said. So what I'm going to do is current nodes, previous nodes, next node. I'm going to set it to none. That's all. It's very simple. What I'm doing, current nodes, which is the last node at now, dot previous node, that is the previous node. So we have to delete the current node. I'm going to current nodes, previous nodes, next node. That means the current node itself. I'm going to set it to none. Okay, let's see whether it is working. So d1 dot delete back. So now look at the output. Previously 100 will be deleted when we run this program. Look, 100 is deleted. So this is how it works. This is the current node. Current node's previous node, that is 12. Next node we are setting to none. That's all. Now we are going for the deletion from a specific position. So same like that one. Delete, sorry, specific. So in this we need the value. So same like insertion, we need the position, or we can give the data. So we can do a change, little change. I'm going to insert, delete the particular data. Okay, so at first same like how we are doing. If it is none, then return there is nothing to be deleted, or we have to current node is equal to self dot head. So now we have to traverse to that position. So why current node should not be done, none dot next node, and item is not the okay, value is not needed, sorry, it's mistake. So we have to search for the item. Okay, so I'm gonna iterate through the linked list and searching for the value is not item. Current node is equal to current node dot next node. Okay, so I'm going to iterate through the linked list and searching for the value. Current node, the value is none, I not item. Okay, so what I'm going to do is, here I'm going to do a little bit different. So consider this is a first node. So I'm going to create a previous variable and I'm going to set it to none. So as we know, this is the current node at start and previous will be here, which is set to none. Okay, so while traversing, what I want is current node will go to the next one, it will search for the value. At that time my previous will be set to this previous node. Okay, so that's what I'm going to do. So I'm going to do is previous is equal to current node, and current node is current dot next. So this is what I'm going to do. I'm going to run through the array, run through the I'm going to run through the linked list, and I'm going to set the previous to current node and current node to current dot next node. So when we reach the node, so consider I have to delete 99. So previous will be 11 and current node will be 99. So I'm going to delete this. So what I'm going to do is previous is 11 as I have told. So previous dot next node I'm going to set it to current dot next node. Okay. So this link will be broken. Previous next will be current's next. That means previous next will be here. Okay. Now we have to link it backwards also. But before that we have to see whether it is the last node. If it is last node, it will cause an error. So if current node dot next node is not none. If it is not none, then I'm going to set previous node is equal to current node. Previous node is equal to current node dot next node dot previous node. Look, if it is, I'm going to delete 99, that is current node. So previous node's next node is equal to current node's next node, that is this one. Then if it is not none, which one, current node's next node is not none, then what I'm going to do, previous will be current node's next node's previous node. Okay, so this will be completely deleted. It's very simple. So let's see whether it is working. So from this list I'm going to delete the one which I have told now, 99. Look, 99 is deleted. Let's also try deleting the 12th node value 12.